In this video, we're going to look at a second method for solving systems of equations called substitution. So hopefully this is not a new word. We've been substituting variables into our problems for a long time now. So substitution, we're just replacing a variable with something that is equivalent. So in the past, we were substituting values. And so if we had something like this equation here, we may say, okay, if x equals 5, because these are equivalent, I can replace 5 in this original equation. So instead of y equals 2 times x plus 1, that x gets replaced with a 5. And because they are equivalent now, we can simplify this and figure out the value. Now it's not going to be just a 5. This is going to be equal to some number. So here's our first example. Because this equal sign means these two are equivalent, this has the same value as what's on the right. So I can make a substitution of everything that y is equivalent to, and I can replace it in this original equation. So instead of saying y equals 2x, I can replace all of this with x plus 5. And now I can just simplify. And again, all of this was equal to y. So I just replaced the y with what it is equivalent to. So I have an equation with only one variable now. And so now I can use my methods from chapter 1 to isolate the variable and figure out what x is. So I'm going to subtract x from both sides, and we're left with 5 equals 1x. And so we found the value of x. And remember, if I were to graph both of these equations, my solution would be their point of intersection. So my solution is always an ordered pair. And what we just found is the value for x. So if x is 5, think about how we can go back and find that y value. And just remember, anytime we need to know the y value, we can use either of these two equations, and we could plug in what we know the value of x is. So if x equals 5, I can plug that in so that I get y equals 5 plus 5, or y equals 10. And so this would be the point where these two would cross. It's also the only ordered pair that makes both of these equations true when I plug them in. So here's an example of where we actually don't know the value of either of our variables. So in order to replace something, I have to know what one of the variables is equivalent to. Basically, I have to have one variable isolated, and I don't have that. So we want to look for something that's easy. And if you notice here, this y already has a number in front of it. So he's probably not close to being alone. But if we look at any of the other three terms, any of these would be really, really easy to get by itself. So I'm actually just going to make a choice here. I'm going to go ahead and isolate this variable. So to do that, I'm going to subtract the y, and I'm left with x equals 3 minus y. So now I know that x is equivalent to 3 minus y. And since they are equivalent, I can use this to make a substitution. So I'm going to replace x in the other equation with what's here in my box. So that instead of saying x plus 4y equals 6, I'm going to replace x with what it's equivalent to here, this 3 minus y. So again, remember, all of this was equivalent to x. So this is my original equation here, x plus 4y equals 6. And now I have one equation with one variable, so I'm going to simplify. So this says I'm going to have 4 y's, and I'm going to take away 1 y. So I get 3 plus 3y equals 6. And then if I just use inverse operations to isolate the variable, I'm going to be left with 3y equals 3. And finally, dividing by 3, I get that y equals 1. Again, just remember, my solutions are ordered pairs. So right now I have my y value. I need to go back and find my x value. And you can plug it into either one of your original equations Or remember, this new equation was equivalent because we just rearranged this bottom equation. So I can plug it into this one if I want. So x is equivalent to 3 minus whatever the value of y is. And we know from here that y is equal to 1. So I'm going to plug in a 1 here. And x equals 2. So this is the ordered pair that is a solution. It's going to be where my two lines cross. It's also the only ordered pair that's going to make both of my original equations true. So our key ideas, before we can begin, we have to make sure that we solve for one of the variables. We have to have a variable by itself. And then we're going to substitute it into the other equation. And then we're always going to solve for the remaining variable because our answer is an ordered pair.